This video demonstration is focused on addressing one of the most common air sources when trying to achieve a good bolted connection. The air sources in this demonstration focus on a common problem known as thread gulling. Surface irregularities produced in the manufacturing of the threads permit points of high friction, ultimately cause torn pieces to become trapped between the threads of the nut and the bolt, commonly called gulling. The thread gulling occurs during installation when pressure and friction cause bolt threads to seize to the threads of a nut or tapped hole. It is also known as cold welding. Once a fastener has seized up from gulling, it is typically impossible to remove without cutting the bolt or splitting the nut. Special anti-seizing or anti-gulling lubricants can be used to dramatically reduce the chance of gulling and corrosion. In this video, the threads on a bolt are severely damaged with a cold chisel. Not just the normal irregular surface shreds that get trapped, but with severe damage to the threads with a mallet and a cold chisel to multiple points. Special anti-seizing or anti-gulling lubricants can be used to dramatically reduce the chance of gulling. What I'm going to attempt to demonstrate is just a simple destroy a couple threads with a cold chisel and then apply the nut and see the end result as it relates to simulation, fairly severe one, of a gulling situation. I'm going to do two threads here. Add the nut, the washer, both stainless steel, as well as the bolt. Engage the first area where I've damaged the thread, and I'm going to torque it down. It's set at 60 foot-pounds. Bottom it all the way out. It won't even go all the way down at 60 foot-pounds, so I'm going to go ahead and increase it. Go up to 90. I still won't go all the way down, so at this point I'm going to go ahead and try to back it back off. And anybody that uses nuts or studs and has to assemble and disassemble them, this demonstration is relative. Because if this seizes up as this has, you're going to have to find another method to get the stud or the nut off, and it's going to add up in time it's going to take you to get back to work. Okay, at this point I'm going to change over and a little bit more severe here. It is completely locked in place. very warm, the heat, friction, and a loose washer. And I'm going to do the same thing now, and as I originally identified, I'm going to use thread lubrication, in this case 783, which is a Chesterton product. And I am going to first mount the bolt same application I did on the prior bolt. And that's pretty severe. I'll actually take a picture of it if I can. Okay. Hopefully you can see that. Damage those threads fairly aggressively. And now what I'm going to do is use the thread sealing paste on all the surfaces where friction can mount up. Doing the underneath side of the head of the bolt, and I'm going to do the threads. And do the underside of the washer. The top side of the washer. And then the underneath side of the nut where it's going to contact the washer, or a Belleville disc spring, whatever the application is. And then I'm going to do the threads. This particular paste is so smooth and silky that it goes and gets in every crack and crevice. I can feel by hand that I engaged the first thread. It was damaged. To the second one now, and I'm going to go back to the torque wrench. Reset it to 60. And continue to tighten it up. Achieved the 60 foot-pounds, and now I'm going to reverse it and disassemble it to disassemble something. This particular lubrication, it aids in prevention of the gulling, as we're demonstrating here, corrosion, and it is
water washout resistant.
I can do this by hand. There's absolutely no friction, and it's perfect.
The summary
The Chesterton 783 thread paste is metal-free, high performance, extreme corrosion protection, and water washout resistant. Its particle size is 3 to 5 mils, which allows it to get in all small cracks and crevices, while our competitors range in size from 10 to 16 mils. It eases in the disassembly of equipment. It fills in all microscopic voids. It's not toxic, and for extreme pressures up to 127,000 psi.